If T1 is the temperature in state 1 and V1 is the volume, the state changes to T2, V2. It means T1, V1 to the power gamma minus 1 equal to T2, V2 to the power of gamma minus 1. That is the meaning of TV to the power of gamma minus 1 is a constant. So this is one equation. We're going to get one more equation for adiabatic process. This is one equation. Alright. But T equal to PV over NR, the equation of state. PV equal to nRT. Solve for T from there. We got T equal to PV over NR. Now, let's replace T here by PV over NR. And what do you get? That will be, this T will be replaced by PV over NR times V to the power of gamma minus 1 is a constant. Alright, tell me, what is V times V to the power of gamma minus 1? Well, I know some of you will have no problem doing this. V means V to the power of 1 times V to the power of gamma minus 1 is V to the power of 1 plus gamma minus 1 is the same as V to the power of gamma. So V times V to the power of gamma minus 1 is the same as V to the power of gamma. Let's rewrite that. Now, and also NR is a constant, is that right? This NR is a constant. So we can now multiply this NR with a constant which will still be a constant. That means we get PV to the power of gamma. You see, V times V to the gamma minus 1 is V to the gamma. We get PV to the power of gamma is a constant. Why? Because NR is a constant. Now, this is the second equation for adiabatic process. So what are the two equations for adiabatic process? TV to the power of gamma minus 1 is a constant. PV to the power of gamma is a constant. Now, we will use any of these equations depending on what are the given quantities that we have. So, two equations for adiabatic process are TV to the power of gamma minus 1 is a constant. PV to the power of gamma is a constant. Tell me, if you still remember, what does this gamma represent? Gamma is the ratio of heat capacity at constant pressure to the heat capacity at constant volume, Cp over Cv. And what is the value of gamma for a monoatomic gas? The value of gamma for a monoatomic gas is 1.67. What's the value of gamma for a diatomic gas? It is 1.4. Okay, let's now talk about work done in adiabatic process. Do you remember the equation for work done in isothermal process? What is an isothermal process? Where the temperature remains a constant. And we derived an equation for work done there. What's the equation we derived? W isothermal is nRT ln V2 over V1. You see, you can't forget these things. I don't forget them. Well, you might say, I have been using them. Yes, that's the way to learn them. Use them. You see, solve problems, use them, and sometimes you can even dream about them. Yes, there's nothing wrong about it. You will not forget them. So, let's now talk about work done in an adiabatic process. Now, for any process, we have, since for an adiabatic process, the work done equal to 0, we have dq equal to du plus dw equal to 0. Therefore, dw is negative du. Is that right? Work done in an adiabatic process is negative of du. What does that mean? This is what I explained earlier. The energy for work done in an adiabatic process is actually derived from the internal energy. That means work done will result in a decrease in internal energy. dw is negative of du. Now that is negative. Now I hope that by now this is familiar to you. Du by dt is Cv. Therefore du is Cv dt. Now this must be, V must be the subscript here, C sub V dt. Now that will be negative Cv. Look at the way I'm going to write this dt. dt is T2 minus T1, the change in temperature. So work done in an adiabatic process is negative Cv times T2 minus T1. Well, if you want to make this positive, I can write this now as Cv times T1 minus T2. Tell me, if it is an adiabatic expansion, will T2 minus T1 be a positive quantity or a negative quantity for an adiabatic expansion? For an adiabatic expansion, T2 minus T1 will be negative. Why? Because an adiabatic expansion causes cooling. T2 will be less than T1. So T2 minus T1 will be a negative quantity. So let's write this using positive value equal to Cv times T1 minus T2. And that is a measure of the work done in adiabatic process. But T equal to PV over nR, the equation of state. PV equal to nRT. And so your T1 can be written as P1 V1 over nR, and T2 can be written as P2 V2 over nR. So dW, work done in an adiabatic process, is Cv times T1 minus T2 becomes P1 V1 over nR minus P2 V2 over nR. nR is a common factor on the denominator which you can factor out. Is that right? That will be Cv divided by nR times P1 V1 minus P2 V2. Now, do you remember the quantity nR? nR is Cp minus Cv, isn't it? Well, we can actually do that, but Cp minus Cv is this nR. We can replace it by Cp minus Cv. Therefore, dW, work done in an adiabatic process, is Cv divided by Cp minus Cv times P1 V1 minus P2 V2. Okay. Is it possible for us to write this quantity in terms of gamma? What do you think? How do we write this quantity in terms of gamma? What is the definition of gamma? Gamma is Cp divided by Cv. So, all you need to do is divide each of these terms. You see, divide the numerator and denominator by Cv. On the numerator, Cv divided by Cv will be 1. On the denominator, Cp divided by Cv will be gamma, minus Cv divided by Cv will be 1. Is that right? So divide by gamma the numerator and denominator, we get dW equal to 1 over gamma minus 1 P1 V1 minus P2 V2. And that is the expression for work done in an adiabatic process. Is it difficult to remember? Work done in an adiabatic process is P1 V1 minus P2 V2 over gamma minus 1. Gamma minus 1 is on the denominator. That's a very simple equation. And work done in an isothermal process is nRT ln V2 over V1. And these equations are very useful when we need to solve problems. Okay? I think